Hello students, we are going to start the chapter carbon and its compounds, okay, the compounds made up of carbon. So when we talk about our daily life, okay, we are consuming many things like vegetables, tea, pulses, rice, okay. What are these? They are all consisting of carbon, okay. And here if we talk about the cotton, okay, this cotton and other any fabrics, okay, these are also consisting of carbon. Carbon actually is a very important element which is forming the compounds and it is used by us, okay. So when this carbon, when we talk about in nature, if we see, okay, it is formed in the free state as well as the combined state. When we talk about the earth crust, from earth crust we get carbon how much? 0.02%, okay. And when we talk about the atmosphere, okay, we in that it is present in the form of carbon dioxide, and yes, here carbon we are seeing that it is how much? 0.03%, okay. So we can say that yes, this carbon is a very important element, but in our environment, okay, and on earth, okay, this is present in very less amount, okay. Now here, if this carbon is present in the living bodies, okay, it is known as what? Organic carbon compounds, okay. So here if we talk about all the living organisms, they are basically made up of carbon compounds. I have said right now in our daily routine we use this pulses, we use this rice, we use this tea, coffee and vegetables and toothpaste, okay. Everything this is consisting of carbon, even the clothes, the fabric, okay, consisting of carbon. It is obtained from what? The living organisms. Again, if I talk about vegetables, from where it is coming? From the plants, isn't it? If I am talking about the carbohydrates, okay, the wheat, the rice, it is also coming from the plants, isn't it? So here carbohydrates, proteins, fats, all are consisting of carbon, okay. Carbon combined with what? Oxygen, nitrogen or hydrogen basically, okay. So all living organisms, if they are made up of this carbon, how can we prove that yes, these living organisms are consisting of the carbon compounds, okay. So if we talk about any carbon compound, okay, so if we talk about LPG also, LPG is what? A petroleum product, isn't it? LPG, liquefied petroleum gas, okay. It is basically butane, okay. You'll be studying in this chapter, and when if you will be heating it, you will be getting what? Carbon dioxide, water and heat, okay. And when you pass it through this lime water, how will you prove that yes, in this carbon dioxide is released, okay. When you pass through this lime water, it changes it milky, okay. We can see a example like CH4, okay. It is a carbon compound, okay, plus oxygen. When you heat it, okay, what will be evolved? CO2 plus H2O plus heat, okay. Here you can just balance it, okay. 2 you can write over here and 2 you can write over here, okay. So you are seeing what? When a carbon compound is heated, we get what? Carbon dioxide, okay. And when this carbon dioxide, CO2, is passed through what? Lime water, CaOH whole twice, okay. You get what? CaCO3 plus H2O, okay. You can balance it if you want. Calcium is 1 over here, it's okay, but carbon dioxide, you can see carbon is 1 but oxygen is 3 plus 1, it is 4. Here oxygen is also 4, so it is balanced, okay. So you are seeing that yes, when this carbon dioxide is passed through calcium hydroxide, you are getting calcium carbonate plus H2O, and this calcium carbonate, because of the formation of this PPT of CaCO3 calcium carbonate, we see that yes, the lime water has turned milky, okay. So this is how we can prove that yes, the carbon compounds, when they are heated, they give out what? Carbon dioxide and water and heat. Okay. Now, if this is the thing, when plants are burned, what we get? We get again carbon dioxide only. Okay. And suppose if the animals are burned, we get this carbon dioxide. Okay. When human beings are also burned, okay, this we see that yes, carbon dioxide is released out and ashes are left over. It means all these living world, okay, living organisms, they are composed of the basic element, that is carbon. And this carbon combining with other elements like oxygen, nitrogen, hydrogen, forming carbon compounds, okay, and which is found in the living organisms, and they are known as organic compounds. Okay. Now coming to the atomic number of carbon. Okay. So carbon's atomic number is 6 and its electronic configuration becomes 2 and 4. See over here, this 4, okay, electrons present in the valence shell of the carbon makes it tetravalent, isn't it? Because the last shell is, the valence shell is consisting of 4 electrons. Okay, so if it is consisting of 4 electrons, we will be seeing here which type of bonding it will make. Okay, so we have studied about the ionic compounds in the chapter metals and non-metals. Okay, we have seen that yes, these ionic compounds, they are formed by the transfer of electrons, like magnesium chloride you have seen. MgCl2 configuration was done for this. So magnesium, okay, has got 2 valence electron, and chlorine, 2 atoms of chlorine are there, having what? 7 electrons, isn't it? We have done in that last chapter of metal and non-metal. And here 1 electron gets transferred, here also it gets transferred, and here we are seeing that transfer of electron is taking place, thereby forming the ionic compound. And yes, when there is transfer of electrons, okay, it has got higher melting point and higher boiling point, because strong electrostatic force of attraction is there between the two elements, atoms of the elements which are combining. Okay, and yes, we are seeing here that yes, when they are in molten state, they conduct electricity, and when we talk about the solubility, they are soluble in water easily because these are polar compounds. Okay, so one is taking the electrons, one is giving the electrons. Okay, so here ionic compounds have these got this features in them. Okay, or these characteristics are present in the case of the ionic compounds. Now talking about this carbon compounds, can they form this ionic compound? Okay, let us see that. So now talking about this carbon, carbon has got 4 valence electrons. Okay, so basically can it form this ionic compounds? Okay, so let us see that. See, the carbon, it has got, it is atomic number is 6, yes, 4 is the valence electron. So it can either lose the or gain the electrons, okay, and get the noble gas configuration. Okay, then but can this happen? Suppose if it is losing the electrons, this carbon, okay, having 4 electrons in the valence shell, it is losing the electron, it means it is giving, or transfer of electrons is taking place. Can it take place? No. Why? Because here the energy to remove these electrons will be more, isn't it? More amount of energy will be required to remove these electrons from the valence shell, isn't it? Here, but, and here one thing more is there, if these are removed, okay, what will happen? 2 electrons will be there, and what will be the criteria of this 6 protons which is present in the nucleus of the atom, and only 2 electrons being there. So if it gains the electron, okay, so what happens? If it is gaining 4 electrons, okay, so here suppose it is gaining 4 electrons from any other atom. So now you will be seeing that yes, the number of electrons over here has increased. It is 2 plus 8, 10 electrons, and in the nucleus only 6 electrons are present. Will it be efficient for these 6 protons present in the nucleus of the carbon to hold these 10 electrons? Here number of repulsions, the repulsion also will rise among the electrons, because now the electrons has been crowded in that shell, isn't it? So to gain these 4 electrons also becomes difficult, isn't it? To lose 4 electrons, tremendous amount of energy required to remove the electrons, and that it becomes very difficult and is impossible. Okay, so here losing of electron and gaining of electron can't work over here. Okay, and thus it can't form a ionic bond. It can form what? Covalent bond, where what will it do? It will do sharing, okay, so that it can get what? 8 electrons in its outermost shell, okay. Like if this carbon is forming a compound, okay, suppose CH4, okay, it will share its electrons. What it will do? It will share its electrons. So it has got 4, and here hydrogen is present, okay, hydrogen also 1 electron is present. Now what it will do? It will share the electrons and it will complete its octet. This is the Lewis dot structure of methane. Okay, so here you can see 1, 2, 3, 4, 5, 6, 7, 8. Now totally its octet is complete, and yes, hydrogen duplet is also complete, and this is a covalent bond. Okay, when we talk about this covalent bond, okay, this covalent bond is also of 2 types: homoatomic covalent bond and heteroatomic covalent bond. Okay, so now let us study about the covalent bond formation. Covalent bond formation. Okay, so here when we talk about this covalent bond formation, okay, it is of 3 types, okay, single, double and triple covalent bonds. Okay, example of single covalent bond, like you can take of H2. Okay, here you can see how many bonds, covalent bonds are being made. Only 1. So this is a single covalent bond. Okay, now coming to the double covalent bond. Okay, take the example of O2. O2, if we are saying oxygen, if we are saying its atomic number is 8, so its configuration becomes 2 and 6. So K shell is consisting of 2 electrons and L shell is consisting of 6 electrons. So here you can see that in this, taking the valence electrons only, Lewis dot structure, we are saying that it is making double bond to complete its octet. You can count the electrons over here, whether the octet is complete or not. 1, 2, 3, 4, 5, 6, 7, 8 complete. Here also 8 complete. So this is a single covalent bond, this is a double covalent bond. Now coming to triple covalent bond, N2. Take the example of N2. Okay, nitrogen, when we are saying its atomic number is 7, so its configuration becomes 2 and 5, isn't it? So here we will be seeing what? That yes, nitrogen, it is having 5 valence electrons, isn't it? And yes, it requires how many? 8. So it will be forming triple bond to complete its octet. Come on, count 1, 2, 3, 4, 5, 6, 7, 8. Okay, complete. Here also complete octet. So we can see these covalent bonds, okay, are of 3 types: single covalent bond, double covalent bond and triple covalent bond. Now coming to covalency. Okay, covalency is the number of electrons, okay, which are contributed for the sharing or the bond formation. Like if we talk about the covalency of oxygen, it is how much? 2. 2 electrons are being contributed by each of the atom of oxygen, isn't it? So for one, if we are saying it is how much? How many? It is 2. Okay. Like here, if we are saying about hydrogen, it is 1. If we are talking about the covalency of nitrogen, it is 3. Okay. So covalency is the number of electrons which are contributed by the atom in the covalent bond formation. Okay. Now next, when we talk about these covalent bonds, okay, these covalent bonds, due to formation of these covalent bonds, the molecules may be heteroatomic covalent molecules or homoatomic covalent molecules. Okay, when we are talking about the homoatomic, okay, homoatomic means same, so it will be H2, okay, O2, these are homoatomic. Okay, the atoms are, the elements are similar. Okay, so here when the bond is being formed in this hydrogen, okay, in this one electrons are sharing, one electron of this hydrogen and one electron of this hydrogen, and naturally its duplet is complete. Okay, likewise it will be for oxygen. These are what? Homoatomic covalent molecules. Now talking about the heteroatomic covalent molecules or compounds. Okay beta, so here we can take the example of methane. Okay, these two you can see are the atoms of different elements. Okay, so carbon, you know that atomic number is 6, so configuration just do that, it is 2 and 4, so valence electrons 4. For hydrogen you all know that it is 1. Okay, so carbon, keeping carbon in the center, okay, here we will be seeing that yes, the covalent bond is formed between this carbon and hydrogen. Okay, in this you can see how many electrons are present in the valence shell. Carbon, it is 4, okay, and for hydrogen it is 1. So now we can say that yes, here what is this octet has been complete for carbon, and yes, duplet of hydrogen is also completed, and thus the formation of CH4, that is methane. So this is an example of heteroatomic covalent molecule, and this is the example of homoatomic covalent molecule. So now students, we have studied about this covalent bond. Okay, now let us study about the properties of this covalent compounds. Okay, this covalent compounds, if we talk about its melting and boiling point, when we compare it with the ionic compounds, the melting and boiling point is less than the ionic compounds. Why it is less beta? Because ionic compounds, there is strong electrostatic force of attraction between the elements which are combining. Okay, but here in case of covalent bond we don't see that. Here only sharing is taking place. So what happens in this? The melting and boiling point becomes comparatively less than the ionic compounds. Okay, when we talk about this electricity, conduction of electricity, they don't conduct electricity. Okay, here actually the sharing is being taking place, not transfer. So for conduction of electricity, charges should be there. Okay, now here force of attraction, when we talk in case of this covalent compounds, is weaker than the ionic compounds, and yes, we are knowing that this is because in ionic compounds the transfer of electrons are taking place, strong electrostatic force of attractions are there, but in case of covalent compounds, strong electrostatic force of attraction is not there. Okay, and as the result what happens, they are not so strong bonds as compared to the ionic compounds. Okay, and yes, when we talk about the ions, here in ionic compounds they give out ions, isn't it? Like NaCl, if we are saying, Na plus and Cl minus. Here we are saying yes, the formation of they can give the ions, but in covalent compounds ions are not given. Okay, and yes, when we talk about the solubility, as they are not polar in nature, okay, what happens? They are basically soluble in organic solvents. Okay, like benzene, you can say CCl4, you can say. So these are the some of the properties of this ionic compounds and the covalent compounds. So next class we will be studying about the versatile nature of carbon. So this is all for today. Good day. Take care.